Thank Levi for brief but very dense presentation, and it's open for discussion.
So you have your several orders, right, of corrections.
Yes.
And the higher the order of the corrections, the smaller the correction is, right?
Yes.
By itself. So, but what to do? What to do if your first order correction equals to 0? Does it mean that you stop?
No. So if your first order correction is 0, you can go to second order. And I know I read some places where they said first order is not a good approximation, so then you go to second order. So there are some cases where you are indeed correct that the first order perturbation theory does not give reasonable corrections, so then you can go to second order. And I would say if I was doing it in like research, I would first try first order and see what happens, and then go to second order, and just so then you don't just add a whole bunch of computational costs to your method before jumping into second order.
More questions? Some of the examples, please provide some of the examples where perturbation theory helps to predict outcome of an experiment in the atomic spectroscopy. Where do you see level splitting?
So, is it shark? No. Stark. You can,
But if you do not remember names, what is the experiment?
so if you have like hydrogen atom and you put it inside of a magnetic field,
Magnetic?
electric,
Hmm?
the energy levels will split, and that is one place where you can try and use perturbation theory.
Which order?
First order. And you can also do like spin orbit coupling, dispersion.
Yeah. Okay, so Stark effect is one of the examples of successful application of perturbation theory. If there are no more questions, but thank you once again. And the next
I
presentation.
do have a question.
Oh,
Just very quick. For the Stark effect, can you see Stark effect not only in electric fields? Like, is it possible to make analogy to the Stark effect in atoms when external electric field is not applied?
Yes, so if you have a nucleus like oxygen that has more than one electron going around it, your energy levels become degenerate. So like your S and P orbitals without multiple electrons would just be constant, and then if you add another electron, it splits.
They non-degenerate.
Yes.
Because?
You have interaction between the two electrons.
Okay, so you have kind of the
Yeah.
internal electric field.
Yes.
More questions? If not, thank you once again. And the next